Welcome to the Sleepy Physicist. I'm so glad you could join me this evening. Whether you're in bed, cozy under your blankets, or relaxing on the couch as your eyelids grow heavy, this is your peaceful space. Here you can let science gently unfold in the quiet corners of your mind. Tonight's topic isn't just about the cosmos. It's about you and how your thoughts drift like a small boat across the vast cosmic ocean. A gentle reminder: I want to gently remind you that if you're enjoying this journey, you might consider leaving a like or even subscribing to this quiet little corner of the internet. It helps other curious minds discover this place. If you're inspired to, you can also leave a comment. Maybe let me know where you're listening from, or what time your journey begins. I love seeing the silent map of the world light up with sleepy travelers. And if you ever wish to support more of these bedtime explorations, there's an option for super thanks, or even becoming a channel member. But for now, none of that is important. All that matters is that you're here. You're safe, and together we'll drift into one of the cosmos's greatest mysteries. The unmoving sky. The stars are not in their original places. When ancient astronomers looked up, they pictured an eternal sky, a fixed and permanent dome. The constellations they traced seemed motionless, like the everlasting guardians of the night. Over time, however, careful observation began to reveal that something more profound was happening. Galaxies, entire cities of stars, weren't staying still. They were moving away from one another, as if carried by unseen tides. Imagine the universe as a vast sheet of fabric, with ink dots on it representing galaxies. If you stretch the sheet gently, the dots don't move on their own. Instead, they drift apart because the very fabric beneath them is expanding. This isn't movement through space, it's space itself stretching, breathing, and carrying galaxies farther and farther away. You can't feel this expansion in your room tonight. Your body, your bed, and the walls around you are all held together by forces far stronger than cosmic stretching. Yet, over the immense distances between galaxies, this effect is undeniable. The universe refuses to be static. It doesn't hold a fixed shape or freeze like a photograph. It moves, evolves, and changes. An accelerating flow. In the universe's early years, scientists once thought that its expansion would slow down, weighed down by the gravity of all the matter within it. But as we looked closer, we discovered the opposite. The universe isn't just expanding, it's accelerating like a calm river that suddenly turns into rapids. Space itself is flowing faster and faster outward. Close your eyes for a moment and picture this. Imagine you're standing at the edge of a wide, dark meadow at night. Fireflies are scattered across the field, glowing faintly. At first, they hover steady and still. Then, slowly, they start to drift away from you, moving outward in every direction. As time passes, they move even faster, their distance from you growing not just steadily, but more and more quickly. You don't chase them, you simply watch. And with each moment, the meadow becomes emptier, the glow more distant, and the silence deeper. This is what astronomers see when they look at distant galaxies: a gentle but unstoppable outward drift. The hidden hand of dark energy. But what causes this? Gravity is a familiar force. It pulls apples to the ground, binds Earth to the sun, and holds galaxies together. Expansion, on the other hand, is stranger. There's no hand pushing galaxies apart, no cosmic wind we can feel on our skin. Instead, there's something hidden, a subtle pressure woven into the very fabric of reality. We call it dark energy. Dark energy is not like the energy you know from warmth, light, or electricity. It's not something you can harness at home or feel with your fingertips. Instead, it's the energy of empty space itself, a whisper of power residing in nothingness. Think of it as a profound silence that somehow still sings, a stillness that carries force. Everywhere you look, even in the emptiness between galaxies, this hidden energy is present. And because it's everywhere, its influence grows as space expands. This force, this dark energy, is why the universe won't stand still. It's why galaxies don't just drift but accelerate. And it's why the future of the cosmos will never be what the ancients imagined: a steady, unchanging sky. Instead, the sky is a moving river, forever flowing away. Your place in the cosmos. It's strangely comforting to know that even the stars are restless, that galaxies are carried by unseen tides. As you lie here tonight, you are part of this motion too. Even though you are held tightly by Earth's gravity, safe and still in your bed, your atoms are drifting with the universe. Every heartbeat, every breath is carried through an expanding sea of space. This idea might sound overwhelming, but notice how gentle it feels. Expansion doesn't tear you apart or unravel the closeness of your body, your home, or your planet. It only acts across the vast empty spaces where galaxies float far from each other. Like the pause between heartbeats, it exists in the immense, not the immediate. So you can rest. You can let the knowledge of this motion carry you into a state of calm. The more you think about it, the more expansion starts to feel like time itself, always moving forward, always stretching the fabric of what was into what is. Just as you can't step back into yesterday, galaxies can't resist the flow of space. The universe carries them on just as surely as time carries you forward in your own life. A cosmic discovery, astronomers measure this acceleration by studying the light of distant stars. Certain stars called supernovae shine with a predictable brightness. By comparing how bright they appear to how bright they should be, scientists discovered that galaxies are farther away than expected. As if carried away by an extra push, these supernovae became cosmic candles illuminating the presence of dark energy. This discovery changed everything. Before, we believed gravity alone would determine the fate of the cosmos, whether it would collapse, expand forever, or find a delicate balance. Now, we know there's another force at play, a hidden power stronger than gravity on the largest scales, one that causes expansion to not only continue but accelerate. Tonight, as you drift between wakefulness and sleep, imagine floating on a raft in a vast, endless ocean. The water beneath you is calm, yet slowly and quietly, the surface swells outward. You can't see the current, but you know it's there, carrying you effortlessly toward the horizon. This is the universe's gift, a reminder that motion doesn't have to be violent. It can be gentle, inevitable, and eternal. The universe refuses to sit still, and so do you. Your mind drifts, your breath rises and falls, your thoughts expand outward into dreams. You are part of the same fabric that stretches galaxies apart, woven into the same silence that sings in the void. A glimpse of the future. As you rest with this thought, you might wonder, if the universe expands faster and faster, what does that mean for its future? Will it stretch into an endless quiet? Or will this hidden energy one day bring a more dramatic end than we can imagine? The answers to those questions lie beyond tonight, in the next step of our journey together. Close your eyes and imagine standing under a dark sky, far from the noise of human life. No streetlights, no rooftops, no traffic. Just you, the earth beneath your feet, and the quiet weight of the stars above. It feels eternal, doesn't it? As if the sky has always been this way, and the constellations are stitched into the fabric of forever. This feeling of stillness is an illusion. For most of human history, people believed the universe was static. The stars burned, the planets followed their paths, and the cosmos was thought to be fixed. Even after astronomers like Edwin Hubble showed that galaxies were moving apart, many still thought the expansion must be slowing. After all, gravity is a universal force. The pull of all matter should act like a brake. Like a stone tossed into the air, it rises for a while but then falls, pulled back by its weight and attraction. Surely, the universe, too, would one day slow its flight and perhaps collapse back in on itself. The hidden motor, but then came the first glimpse of something different. In the late 20th century, two teams of astronomers set out to measure the cosmos' expansion more carefully than ever before. They looked to a specific type of star that has a dramatic, fiery end, supernovae. These were not just any stars but special kinds whose explosions could be measured like cosmic clocks. They always reached a certain, predictable brightness. By comparing their true brightness to how faint they appeared across the vastness of space, astronomers could figure out how far away they were. These stars became markers in the darkness, candles flickering across billions of years. Imagine holding a candle with a steady, bright flame. Now imagine carrying it farther and farther away until it's just a faint glimmer at the edge of your sight. If you know how bright the candle should be, the difference tells you its distance. This was the trick astronomers used. They scattered these candles across the night and measured the universe's expansion through their glow. What they found was quietly shocking. The supernovae were dimmer than expected. They were farther away than the slowing models predicted. The galaxies weren't just drifting apart, they were accelerating, like leaves on a river that speeds up as it widens. The galaxies were being carried faster into the unknown. The universe wasn't slowing down at all, it was racing forward. A different kind of universe. Take a gentle breath. Feel how strange this is. We live in a cosmos that defies our initial intuition. It doesn't behave like a ball thrown upward, slowing then falling. It acts like something with a hidden motor, a constant push that grows stronger as space gets larger. This discovery was like watching a child run up a hill faster and faster when you expected them to stumble and slow down. The astronomers themselves could hardly believe it at first. They checked their data, compared notes, and questioned if something was wrong with the stars, the dust between them, or the way they measured brightness. But the pattern held. Two separate teams using different telescopes and different methods saw the same truth: the universe was accelerating. This was the first clear glimpse of dark energy. No one saw it directly, no telescope photographed it, and no instrument measured its particles. Instead, it revealed itself only in motion, in the way galaxies behaved. It was like finding footsteps in the snow with no traveler in sight. You know something passed by, you see the evidence, yet the being remains invisible. Think of it this way. If the cosmos were an orchestra, gravity would be the deep drums pulling everything together, slowing the outward rush. But as astronomers listened closer, they heard another instrument playing, a quiet, persistent flute. Its song wasn't pulling inward but pushing outward, carrying the music toward a crescendo. At first, it seemed impossible. Yet, there it was, faint but undeniable, reshaping the entire score. When the news spread, the scientific world shifted. Cosmology had to be rewritten. Instead of a universe ruled by matter and gravity, we now lived in a universe dominated by something invisible and repulsive. Repulsive not in the sense of unpleasant, but in the sense of pushing away. It's a form of energy embedded in the vacuum of space itself. The first invitation: close your eyes again. Picture yourself standing at the edge of a lake. Toss a leaf onto the surface and watch it drift. You expect it to slow as the ripples fade, but instead it glides faster, carried by a current you cannot see. The water seems calm, yet something beneath is driving it forward. That hidden current is like dark energy, a presence we cannot touch, but whose effect carries everything farther. The first glimpse of this truth didn't answer questions, it opened more. What is this hidden energy? Why is it there? Has it always been part of the cosmos, or did it awaken at some point in history? Could it change over time, or is it fixed forever? These questions lingered and still linger today. The first glimpse was not an explanation but an invitation, and you are part of that invitation. Every moment you exist, you live in a universe whose expansion is accelerating. You breathe in the air safely in your room while countless galaxies recede ever faster into the deep. You will never see this motion with your own eyes, for it happens across billions of years. Yet, you are carried with it all the same. The beauty of science isn't only in its answers, but in how it teaches us to sit with wonder. Tonight, as you rest, you join the astronomers in their quiet surprise. You too glimpse the accelerating cosmos not through data but through imagination. You don't need a telescope. You need only to know that the stars you see tonight are not fixed. They are drifting, hurried along by an unseen breath. Let yourself feel the comfort in this. The universe is not stagnant. It's alive in its own way, changing, moving, and restless just as you are. Just as your thoughts drift and your breath rises and falls, so too does the cosmos stretch. Expansion isn't foreign, it mirrors your own rhythms of motion. And so, the first glimpse of acceleration became the first whisper of a greater story. A story in which energy hidden in nothingness dominates the fate of everything. A story in which the universe is not a steady stage but a restless traveler. A story that carries us toward a future none can fully see. Looking to Einstein as you settle deeper. Consider this: if the universe is accelerating, our view of its past may be blurred. The light that reaches us tells an ancient story, but the stage itself is changing even as we look. To understand this, we turn next to one man whose equations hinted at a constant force long before we believed it existed. A man who once called his idea a mistake, but whose vision may have been closer to the truth than he imagined. The glimpse has been made, now comes the reflection, and it leads us gently toward Einstein. Imagine sitting at a desk in the early 20th century. Papers are scattered, chalk dust floats in the air, and a man with a restless mind bends over his equations. His name, of course, is Albert Einstein. His hair, already untamed, reflects a spirit that doesn't easily accept boundaries. He is wrestling with the cosmos, trying to write its story in the language of mathematics. Einstein had already reshaped our understanding of space and time. With general relativity, he showed that gravity was not a force in the usual sense, but the bending of space-time itself.